Hi everybody, welcome to another video for the chemistry series. Today we're going to talk about the periodic table. I'm sure those of you that have been tutored by me this term have heard me harp on and on and on and on about the periodic table. But if you understand it, it will make it a lot easier. The periodic table is broken up into groups, periods, it has trends. We're going to talk about the groups. So group 1 are alkali metals. So sodium, they have one valence electron. The group number indicates the number of valence electrons. They will also lose one electron to get to their octet state. Group 2 has two valence electrons. Calcium is an example. Calcium exists as a 2+ cation and will lose 2 electrons to get into its octet state. Group 3. A lot of people get confused because on the periodic table this is group 13, and that's because in sort of high school and first year we don't really worry about most of the transition metals. So group 13 is group 3. Group 3 exists as a 3+ cation, has 3 valence electrons, and will typically lose 3 electrons to form an octet. So we get to group 4, which is carbon and silicon are the top two. They have 4 valence electrons available for bonding, and this will build into our organic chemistry. So it shares 4 of its electrons with other atoms so that they both come into their octet state. So if it were hydrogen, it would share 4 bonding pairs with hydrogen. Carbon is in its octet state. Hydrogen only requires 2 electrons in its outer shell to be stable or to achieve its octet state. Group 5, nitrogen sits, has 3 valence electrons. And if we're looking at organic chemistry, typically nitrogen will have a triple bond with carbon. Group 6 is oxygen. It's 2 valence electrons, typically takes on a 2- anion is its normal species, O2-, and will form double bonds with carbon in organic chemistry. And then we have group 8, which has 8 valence electrons. They, for all intents and purposes of what we're learning, they do not react. They are stable. They are used in medical gases, things like that, because they're stable and inert.